He knows a lot about the science stuff. Professor Dave explains.
Okay, let's check out a problem regarding the molar mass of a gas. The question asks, an evacuated glass vessel weighs 50.0 grams when empty, 148.0 grams when completely filled with a liquid of density 0.98 grams per milliliter, and 50.5 grams when filled with an ideal gas at 760 millimeters mercury at 300 Kelvin. What is the molar mass of the gas? So certainly we're going to be dealing with ideal gases and all of the equations that relate to them. So if you want to review, check out some of my tutorials on this subject, and when you're ready, give it a try. Okay, first let's do some very basic calculations to get the values that are going to be relevant. First, we're told that we have some liquid, and we know that the vessel filled with liquid is 148 grams, and then without the liquid is 50 grams, and so simply by subtraction, we know that the liquid has a mass of 98 grams. That is the mass of the liquid that completely fills this glass vessel. Then we know that the density of the liquid is 0.98 grams per milliliter. So if we want to get the volume of the liquid, we know that 98 grams divided by 0.98 grams per milliliter is going to give us 100 milliliters. And so that's important because if we have 100 milliliters of liquid and that liquid completely fills the vessel, that means that the volume of the vessel itself is 100 milliliters, which is relevant information. Because now we're going to look at the gas. We're told that when the vessel is filled with this gas, it has a mass of 50.5 grams, and then again, when empty, it's 50 grams. So the mass of the gas is 0.5 grams. Now we have all the information we need to start using the ideal gas law. We know that the vessel has a volume of 100 milliliters. We know that the internal pressure is 760 millimeters mercury. We know that the temperature is 300 Kelvin. And then we do have a mass here of 0.5 grams. And we're going to use this mass in conjunction with the moles value in the ideal gas law. So let's get our ideal gas law. As we know, that is PV equals nRT. Now the thing is, we're going to want to do something with moles so that we can express this in terms of mass, because we have a mass and we want to figure out molar mass. So we know that molar mass is equal to mass over moles, right? If we have some grams value and we have some moles value, number of grams over number of moles, that's grams per mole. That's the molar mass. So let's rearrange that expression and plug it in where moles is. So if big M equals little m over n, then we can solve for moles, and we can say that moles is equal to little m over big M. So moles is equal to mass over molar mass, and we can then plug that in instead of moles in our ideal gas law. Then, since we are looking for molar mass, let's solve for molar mass. Let's solve for big M in this equation. All we have to do is multiply both sides by molar mass and then divide both sides by pressure and volume. So big M equals little m RT over PV. Then we just plug in what we know. So for mass, we know we have 0.5 grams of the gas. Then we have the gas constant, which as always is 0.0821 liters atmospheres per mole Kelvin in this kind of context. And then for T, we have 300 Kelvin, that's given to us. And then for pressure, let's be sure to convert this into atmospheres because we have atmospheres in our gas constant. So luckily 760, we should remember, is equal to 1 atmosphere for millimeters mercury. And then the volume is what we solved for earlier. We know that we have a 100 milliliter vessel. Again here, let's change to liters to match our gas constant. So that's 0.1 liters. So we plug that all into our calculator and we get 123 grams per mole as the molar mass of this gas.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.